Today we are entering a topic that is physical world and measurement. The first question is a radius of a ball is 5.4 plus or minus zero point 0.2 centimeter. The percentage error in the volume of a ball is dash. I repeat the question. Radius of a ball is given as 5.4 plus or minus zero point 0.2 centimeter and you have to find out the percentage error in the volume of a ball. The given data is the radius of a ball. So from the data that is 5.4 plus or minus zero point 0.2, you take the value r as 5.4 and delta r as 0.2. Since you have to find out the volume, then the percentage error will be equal to 3 into delta r by r into 100. On substituting the value for delta r as 0.2 and r as 5.4, you get the answer as 11%. The question once again, radius of a ball is 5.4 plus or minus 0 0.2 centimeter. The percentage error in the volume of a ball is option A, which is 11%. Moving on to the next question. A body travels uniformly a distance 13.8 plus or minus 0 0.2 meter in a time 4 plus or minus 0.3 second. Calculate its velocity with error limits. I repeat, a body travels uniformly a distance of 13.8 plus or minus 0 0.2 meter in a time 4 plus or minus 0.3 second. Calculate its velocity with error limits. So from the question you can pick up the data, that is distance is given as 13.8 plus or minus 0 0.2. Time t is given as 4 plus or minus 0.3, where velocity will be equals to distance by time, that is s by t. Substituting the value for s as 13.8 and time as 4, you get the answer as 3.45 meter per second, which is approximately taken as 3.5 meter per second. Here you find the velocity. Next, you have to find out the velocity with the error limits. So, the data will be delta V by V will be equal to plus or minus delta S by S plus delta T by T. Substituting the value for delta S as 0.2 and delta T as 0.3, S as 13.8 and T as 4. You get the answer plus or minus 0.0895, which is equal to delta V by V. So you have to find out the delta V. That will be equal to 0.0895 into velocity V. You have find out the velocity V as 3.5 meter per second. Substituting the values, you get the delta V as plus or minus 0.31. Hence, the answer will be 3.5 plus or minus 0.31 meter per second. The question once again, a body travels uniformly a distance 13.8 plus or minus 0 0.2 meter in a time 4 plus or minus 0.3 second. The velocity with error limits is option B, 3.5 plus or minus 0.31 meter per second. Moving to the next question, that is Newton meter square per kilogram square is a unit of what? I repeat, Newton meter square per kilogram square is a unit of what? The options given is surface tension, momentum of force, gravitational constant and torque. I'll explain each option in detail and its unit. Okay. First one is the surface tension. Surface tension is the ratio of force to length. That is, surface tension will be equal to force by length. The unit of force is Newton and unit of length is meter. So, surface tension unit will be Newton per meter. Next is the momentum of force. Momentum of force is a product of force and distance. So force in a unit, Newton, and distance unit is meter. So momentum of force will be force into distance, hence unit will be Newton meter. Next is the gravitational constant, which is equal to force into r square by mass square. That is force into radius square by mass square, where unit of force is Newton, radius in meters, so the radius square will be given as meter square, divided by mass, that is kilogram. So mass square will be written as kilogram square. So unit of gravitational constant is Newton meter square per kilogram square. Last option is the torque. Torque is also same as that of momentum of force, which is a product of force and distance. So unit will be Newton meter. Our question was Newton meter square per kilogram is a unit of option C, gravitational constant. Next question is the dimensions of resistance into capacitance are same as that of dash. That is, the product of resistance and capacitance will give the answer which has a dimension quantity will be equal to what? Resistance equal to voltage by current and the capacitance will be charge by voltage. Therefore, product of resistance and capacitance will be equal to voltage by current, which is the resistance, into charge by voltage, that is the capacitance. Okay. So voltage gets cancelled off. We'll get the answer as charge by current. Now what is a charge? Charge is current into time. So substituting current into time in case of charge divided by current. So current gets cancelled off. We get the final answer as time. So the dimension of resistance into capacitance are same as that of time. The next question. A wire has a mass 0.3 plus or minus 0.003 gram with a radius 0.5 plus or minus 0.005 mm and length 6 plus or minus 0.06 centimeter. The maximum percentage error in the measurement of its density is dash. I repeat the question. A wire has a mass which is represented in gram, that is 0.3 plus or minus 0.003. Radius represented in mm, 0.5 plus or minus 0.005. And length is represented in centimeter, where 6 plus or minus 0.06. The maximum percentage error in the measurement of its density is dash. So the data given is the mass, radius and length. From the given data, mass will be represented as m. So delta m has a value of 0.003 and m has a value of 0.3. Then radius will be represented as r. So r will be equals to 0.5 and delta r will be taken as 0.005. Similarly, length is represented as capital L. So delta L will be 0.06 and L will be 6. Okay. Now what is mean density? Density is equal to mass by volume. Mass will be represented as m and volume will be pi r square L. Since it is a wire. Therefore, delta rho by rho into 100, that is the percentage error in the measurement of density, will be equal to delta m by m plus r square. So 2 into delta r by r plus length delta L by L into 100. Okay. Now substituting the values of delta m, delta r and delta L and L, we get the answer as 4%. Okay. So the answer is, that is, the wire has a mass of a particular mass in gram, radius in mm and length in centimeter. The maximum percentage error in the measurement of density is option D, that is 4%. Moving on to the next question, that is, if a time period of oscillation of a pendulum is measured as 2.5 seconds using a stopwatch with the least count half second. Then the permissible error in the measurement is what? I repeat, if the time period of an oscillation of a pendulum is measured as 2.5 seconds using a stopwatch with the least count half second, then the permissible error in the measurement is dash. The given data, that is time, is given as 2.5 seconds and the delta t is given as half second. So permissible error in the measurement of time period will be equal to delta t by t into 100. Substituting the values for delta t as half and t as 2.5, you get the answer as 20%, which is the option D, that is 20%. Okay, that is, if the time period of oscillation of a pendulum is measured as 2.5 seconds using a stopwatch with the least count half second, then the permissible error in the measurement is 20%. The Hubble constant has a dimension of dash. I repeat the question once again, that is, the Hubble constant has the dimension of dash. What do you mean by Hubble constant? Hubble constant means it is the ratio of speed of galaxy to the distance of galaxy from us. That is, in general or in simple words, you can say it as speed by distance. That is, will be equal to time inverse, that is 1 by time. So the Hubble constant has the dimension of option B, which is time inverse. Next question, the voltage V is equal to 100 plus or minus 5 and current I is equal to 10 plus or minus 0.2. The percentage error in resistance R is dash. I repeat the question, the voltage V is given as 100 plus or minus 5, where V will be taken as 100 and delta V will be taken as 5. Similarly, the current data also, I will be taken as 10 and delta I will be taken as 0.2. You have to find out the percentage error in resistance R. So what do you mean by resistance? Resistance is the ratio of voltage by current, that is equal to V by I. Substituting the value for V as 100 and I as 10, you get the resistance value as 10 ohm. Next, you have to find out the percentage error in resistance R. So, the percentage error in resistance R will be equals, that is delta R by R, will be equal to plus or minus delta V by V plus delta I by I. Substituting the values for delta V as 5, delta I as 0.2, V as 100 and I as 10. So, you get the value as plus or minus 7 by 100. Since it is a percentage error in resistance, you have to multiply with 100. So you get the answer as plus or minus 7%. I repeat the question. The voltage V equals 100 plus or minus 5 volt and current I is equal to 10 plus or minus 0.2 ampere. The percentage error in resistance R is option C, that is 7%. Thank you.